Today we will look at time value of money, and another time of value of money, we will look at how to compute our future value using simple interest, using compound interest. Thereafter, we will look at how to compute annuities for the future value and for the present value. Now, simple interest is given by the following formula. Simple interest is simply PTR. Now, P means our principal, the money we have now. T means the time in years, and R means our interest rate. So our compound interest is simply the difference between the future value and the present value that we have. And our future value is simply given by present value 1 plus interest rate to the power time. So you must understand that time can be in terms of what? Years. So when it's compounded annually, means it's earning interest once. If it's compounded semi-annually, it means earning interest twice. If it's compounded quarterly, it's 4 times. Monthly is 12 times. Weekly is 52 times. Daily, it is 365 unless otherwise mentioned. So this is our guide. So if the compounding of interest is done more than annually, the formula will slightly change. Our interest rate will be divided by the number of compounding, and the time will be multiplied by the number of compoundings. So take note that the time is always divided by the number of compounding, and the interest rate is divided by the number of compounding, and the time is multiplied by the number of compoundings. So it brings about an interesting interest rate, which we call the effective annual rate. This gives us the real interest rate that is either earned or charged. So if you're given an interest rate which is compounded more than once, the real interest rate is actually different from the nominal interest rate that you have. For instance, if your interest rate is 12%, and you're told that you're compounding this quarterly, so you're being asked to compute our effective annual interest rate. So we know that quarterly means what? It's compounded 4 times. 4 means our interest rate, or the real interest rate in this case, will be 12% divided by 4. And 4 here, subtract the 1 there. So this will give us, where there's m, we put a 4. So when you divide this in there, we're going to get 1.03 to the power 4. And you subtract a 1. So this will give you the real interest rate, which is 12.55%. Now let's get back to what our question is asking. We'll start with simple interest. When we're dealing with simple interest, we are using the formula interest is equal to PTR, time is in years. Now, we're going to look at this question here, where you're asked to say, suppose we have 1,000 kwacha, which is earning a simple interest of 7% for 2 years. What is our interest rate at the end of the second year? So principal is 1,000. The interest rate is 7%, which is 0.07. And our time is 2 years. So when you multiply this, we're getting our interest as what? 140. So this is just the interest. As a future value that you're going to have after 2 years is simply the principal which is the amount we started with, plus the interest that we've earned, the 140. So meaning our future value and the simple interest will be 1,140. So a future value is simply the value at some future time that you're going to have of the present amount that you have evaluated within a given interest rate. So what is the present value therefore when we're computing the present value of our simple interest? So because we said simple interest is equal to what? Principal times the time times the interest rate. So the present value is simply the current value of the principal given our series of payments. So we can also compute our future value using what is called compounding. To compound is to earn or accrue interest. So the future value is present value 1 plus r to the power time. So this is if we're dealing with more than one period. If you're dealing with a single period, even without time, because this is the same as power 1. So this is the formula that we'll be using. So you can use tables or you can use the formula to calculate the future value. So using the future value, you can either compute the future value, the present value, the interest rate, or the time by manipulating this standard formula. So we're going to look at an example of how to calculate the future value using compound interest. The same question, we have 1,000 kwacha at a compound interest of what? 7% in 2 years. What is the future value? So we're looking at an amount that we have now. How much will it grow to in 2 years? So using the formula, future value is equal to present value 1 plus r to the power t. So our present value is 1,000. Our interest rate is 7%. And our time is 2 years. When you compute that one, it will give you a future value that you're going to have in 2 years. So this is using the computation. So 1 plus r to the power time. So for the first year, you're going to get 1070. For the second year, you're going to get 1144. So meaning you have earned $70 and $4 of interest. So our future value is 1144. So you can see that the interest in here is 144.90, the total interest in 2 years, compared to the simple interest we had for the same question under simple interest, which gave us something slightly smaller. We have found 140 exactly as our simple interest. So sometimes you'll be asked to compare the two models, which one is giving you a high interest rate and which one would you go for. So there we had 140, here we had 140. So this is the general formula that we use when you're computing our value for the simple interest and compound interest. Sometimes you'll be asked to use the tables. These tables I sent to you. You need to make sure that the title is written future value PV IF. So if you're asked to find the future value, okay, we use present value, and we use the present value, the future value interest factor table, rate against time. So we started with the 1,000 kwacha, the 1,000. Our interest rate here is what? 7%. And our time is what? 2 years. So the way we're doing it in QM, we're using such, but these are financial tables. So 7% under 2 years, we're going to have what? 1145. So here, 1145. So when you multiply that, 1,000 times 1145, we're going to get 1145 or 1,145. So this is our future value using the tables, the difference is what? Very minute. So the tables, other people find them very easy to use. So 1145, multiply that. This is due to rounding off. Are we following? Are we together so far? Now, suppose you're asked to find the future value given the present value of 1,000. The interest rate is 8% and the time is 5 years. So using the table, we're going to simply say future value after 5 years will simply be the present value and the future value interest factor table, which is at 8% for 5. For 1,000, we're going to check under 8% and under 5. We have what? 1.469. So if we're going to multiply that, you simply give us 1469 as our future value. You're getting the use of the table. This is how we use the table. It is very easy to understand. The only confusion comes about if you don't know which table to use when. So let's look at another problem here. Mila wants to know how large her deposit of 10,000 today will become if there's an annual compounding interest rate of what? 10% after 5 years. So in this case, we want to compute our future value. So the 10,000 is the amount we have today. Then at 10% for 5 years. So meaning the future value interest factor. If you're using the table, you check under 10% and under 5 years. So you go under 10%. So the table, when you go, this one ends at 8%. So you can check on a table under 10% under 5 years. I had sent you tables which you could relate to. But if you don't have tables, I've emphasized that the formulas are very important. So future value is equal to present value 1 plus R the part time. So we have 10,000 and our interest rate is what? 10%, and we have 5. So when you compute that, you're going to get your figure. So in this case, you're going to compute this using the formula. We're going to have 1.10 to the power 5. It will give you 16,105. But if you're going to check from the table 10% and relate it to 5, this figure will give you 1.61. So this figure, 1.611, when you apply it to the 10,000 to give you 16,110. So this is the figure. You see the difference is small because of rounding off. So sometimes you may be asked to calculate time. You may be asked to calculate the interest rate. You may be asked to calculate other parameters. So this is using an annual compounding. How long or how much will it grow to? We found that here we had calculated 16,000, 16,105.10. This was annually. Suppose you asked to calculate quarterly, what will change? The formula. Our future value will therefore be present value 1 plus R over M to the power MT. So we have 10,000. Our interest rate is 10%. But because it's quarterly, quarterly means 4. If they said monthly, you would have divided by 12. If we said weekly, you would have divided by 52. If we said daily, you would have divided by 365. So quarterly, it will give us 1.025. So you also need to understand that the more you compound, the higher the what? The figure, because you're earning interest several times. So here we're going to get 16,386. Okay, 0.16. So you're seeing that now the figure has grown from 16,100 to 16,300 because you're compounding more than once. Suppose you're asked to find continuously how much it would grow to. Future value continuously will be the present value, e to the power RT. So our 10,000 will be here. Our e is from the calculator. Our R is 10%. Our time is what? 5 years. So 1 times 5, then e is on the calculator. You go to second function, e. Then 5 times 10,000, we're going to get 16,487.21. So you see, the more you compound, the higher the figure. From 16,100, 16,300, 16,400. So this is when you're compounding continuously. This is when you're compounding continuously. This very question you may even ask to be calculate the effective annual rate. So we know our interest rate is 10%. And we're asked to compute the effective annual rate monthly. Effective annual rate doesn't have a time factor. So effective annual rate is simply what? 1 plus R over M, M minus 1. So in this case, we're going to have 10%. Then here we're going to have monthly. We said it is 12 times. So when we compute the figures inside there, we're going to have 1.008 to the power 12 minus 1. So when you compute that, it will actually give you the effective annual rate, which is 10.4%. So this is how you calculate the effective annual rate. Now, sometimes you'll be asked to calculate time. For instance, how long we have this same present value, 10,000. How long will this 10,000 grow to a future value of 30,000? In other languages, it would say how long will this 10,000 triple? Just know it's multiplying by 3 at an interest rate of 8% compounded annually. Now, in this case, just using subject of the formula, future value is simply given by the present value, 1 plus R to the power time. Our future value is the bigger value. So 30,000 is equal to what? 10,000. The interest rate is 8%. At our time, we don't have. So we divide physical size by 10,000. So that this 10 gives you a 3. Then you introduce the logs to get rid of the t. So log 3 is equal to log 1.08. Then the t will fall down, give you an ability to solve for t. For t will be log 3 over log 1.08. So this will give us a compute log 3 divided by log 1.08. If you want, you can use ln 3 divided by ln or in depending on who taught you. So this will give you 14.27 in years. Time is in years. Same question will be, we have the same present value of 10,000. How long will it take to double? To double meaning to grow times 2 to 20,000. Not how long, at what interest rate will it grow in 4 years. So we are compounded annually. Same, we use the same annual formula, which our value is equal to present value 1 plus R per time. So here we have 20,000, and here we have 10,000, and our rate we don't have, so we leave it as it is. The power 4, 10,000, 20,000 is 2. So our rate is protected in the brackets, so we can't remove the brackets unless we multiply by the reciprocal of the power. If there was 10 there, I would have written 1 over 10. If there's 4 there, we write 1 over 4. So that the brackets come out. But we know 1 over 4 is the same as what? 0.25. So meaning we're going to power the 2, the power 0.25 to get us to 1.189. So when this one goes inside, it will subtract, leaving our interest rate to be 18.9%. So this is how long 10,000 will double in 4 years at 18.9%. Sometimes they ask you how much school fees, if school fees at Unilas have to be paid is 30,000. How much must I deposit now? It means the present value in a bank which gives you an interest rate of 10% within 5 years, compounded annually. So now, how much must I deposit? So we know that future value is equal to present value, 1 plus R per time. So if you divide 1 plus R per time, 1 plus R per time, it gives us a present value to be the subject of the formula. So future value is equal to 1 plus R the per time. And our future value in this case is 30,000. So 30,000, and here we have our interest rate, which is 10%, 1.10 to the power 5 years. So 1.10 the power 5. Then we're dividing 30,000 divided by the answer. The future value is usually bigger than the present value. So we're going to have 16,627, 18,627.64. So this is how much you need to deposit now if you want to grow 30,000 in a period of 5 years. Well, we can also use a number line to find how much we're going to have in the end of 5 years. Suppose in year 2, year 3, you're going to, you start with the 10,000 now. In year 2, we have maybe 20,000. In year 3, maybe you have 15,000. How much are we going to have in 5 years at an interest rate of what? 8%. So you can compute this future value, its present value, 1 plus R the power time. So present value is what? 15,000. Our interest rate is what? 8%. But the key thing is the time factor. How long is it taking from the year 3 to year 5? Is 2 years. And this 20,000 future value is equal to 20,000. How long is it taking from year 2 2 year, 5, it is 3 years. And this 10,000, how long is it taking from year 0 to year 5? It's taking how many years? 5 years. So you add these future values. First one being 17,496. Second one being 5,194. The third one being 14,693. And you add all these, 25,194.24 plus 17,496. So you're going to have 57,383.52. So this is the future value if you're given a mixed cash flow. This is how this is done. This is how this is done. So this is the most complex part of it that you need to understand. And the other way around, you'll be asked to say, what is our present value now? If you expect 20,000 after 5 years, 10,000 after 3 years, and the 5,000 after 2 years. So the way we're calculating NPV is the same way we're doing this one. So we know the present value is simply equal to what? Future value over 1 plus R per time. Here, if our interest rate is 4% annually, so we're just going to divide this one 1.12 to the power 2, 1.12 to the power 3. Goodness with this one, the respective numbers that are there are the ones that you use. So this 5,000 today is not worth 5,000. You divide it by our discount factor. It is actually 3,085.97. This one, the 10,000, divided by 1.12 to the power 3. It will give us, instead of 10,000, we get to get 17.80. And finally, this one, 20,000, divided by 1.12 to the power 5. We're going to get 11,348.54. When you compute this, plus 7117.80 plus 3985.97. So this will be 22,452.31. So this is how we find the present value with mixed cash flows. So the next will be on annuities. In the evening, please read on annuities, what annuities are, and also read about how to amortize. So this is where we end, unless there are any questions.